today we're solving quadratics. So in the past when we solved quadratics we may have found ones which have no solution, but now that we have complex numbers at our disposal we can find solutions. So start with some simple ones. Again, last year we've done a little bit of this. Alright, so over C just means you can have complex number answers. If it's over R, which is what we do in methods, then we can't have complex number answers, we're only after real. So over C, complex answers, so again of course using I squared equals -1. Expressions such as z squared plus 16 equals 0 can be solved. Alright, so if z squared plus 16 is equal to 0, if we then take this plus and we change it to a negative, then as we know we can't just change things, we've got to balance it out somewhere. So if we have the I squared, so I squared is -1, that negative there, we've got our positive. And so then in that case we can then factorise because we've got a difference of perfect squares. And so z plus 4i, z minus 4i is 0, and then null factor law. So z is minus 4i, or plus 4i. Alright, and so we can do that, use this in many different ways. So let's have a look at some more examples that are a bit more complex. All good so far? Alright. If I want to factorise z squared plus z plus 3, then some of our quicker factorisation methods are not going to work for us. So we have to resort to completing the square. Alright, so we're going to have to complete the square to factorise. So I'm going to group first two terms together and create a perfect square. And so inside here I will have z plus half. Someone say half? So of course when I expand that, have a quarter up there, then I've got to take a quarter over here to keep it balanced. 3 take a quarter is 2 3/4, and 2 3/4 as an improper fraction is 11/4. Is that what someone said? No one said. All right, so now is when we, because normally, so why we want to complete the square is so that we can then use that difference of perfect squares method to factorise. But we haven't got a minus here, we've got a plus. So that's where we again need to change it to a minus and have that I squared in there. So we'll have it z plus a half, 11/4. And so now, to factorise, 2 brackets, find that difference of perfect squares pattern in the front, z plus a half, plus in one bracket, minus in the other, square root of 11/2, I is in the back of the brackets. Alright, anything there? Anything clarifying? Went through that a little bit quickly for anyone? No? They're all good? Alright, this one looks fun. Alright, next example. Another factorising one. Z squared minus Alright, so the coefficients of those terms don't have to be real numbers. So here we've got the coefficient of z that's a complex number, and we've also got a constant on the end that's a complex number. Alright, so again we're going to have to resort to the completing the square method. It's longer and more algebra. So we've got 2 here in front of the z squared, so we need to, first of all, before we go any further, take that out. And I'm going to write that constant on the end as 4 minus 3I over 2. That just helps me keep it all together. So rather than writing it as 2 minus 3 over 2I, can kind of get a little bit messy there. So by doing that, it just keeps that term all together. All right. So I've left that gap there because I'm going to create my perfect square out of these things. And so we do the same as we did before. Leave the 2 out there, on its own business. Alright, z minus, and then of course we just half that. So same process, half that. Half of that is 3 minus I over 2. Then of course, if we expanded this, we'd have a term on the end, which is again just this one squared. So plus 3 minus I squared over 4. And of course, if I've added that, I've got to take it away. We're all good so far? Haven't gone too quick there about anything? No? Alright, so now we need to do something with all of this stuff. Alright, so I'm going to this term here, I'm going to times the top and the bottom by 2 so that I get a denominator of 4, because I need to put all this together. So we've got 8 minus 6i over 4, and I want to expand that stuff. So 3 minus I times 3 minus I, 9 minus 6i plus I squared. Oops. Minus 1, so it's 8 minus 6i. Yes? No? Yes? Now what do you notice? Anything? Nobody notices anything? Oh, thank you. Yes, so now these two things here are the same, aren't they? So you've got plus that, minus that, so that's gone then, isn't it? So my final answer then, there they go. Those square brackets, now not necessary. So my final answer is 2z minus 3, oops, z minus 3 minus I over 2 squared. Squared. Alright, so let's complete the square method that you've been doing since year 10. We didn't do it in year 9. No. No, in year 10. Well, I know you did it in year 10. You did it with me. Alright. Alright, so you just got to take a bit more care so that you're not getting lost with some of the algebra stuff. Yeah. So if you need to, just to the side do something like that so you don't confuse yourself, then it's worth spending that little bit of time to do that. Alright, one more example. Alright, solve for z. So all of those were factorising, so this time I'm going to solve for z. And so what we've got is z squared equals 2z minus 5. Alright, so the first step would be to get it onto one side. So yeah, always we're going to solve things, we want to make it equal to 0, then we can factorise, use the null factor law, or if that's not going to work, we can use the quadratic formula, yes. Alright, so yeah, we could go through that, complete the square process and factorise it, but the quadratic formula's already done all of that for us. So in this case, z equals negative b plus or minus the square root of b squared minus 4ac, all on 2a. So that works exactly the same. So here z, b is 2, so the negative of that's just 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 5, all on 2 times 1. We've got 4 minus 20 on 2. Which is 2 plus or minus the square root of negative 16. And what do we do with the negative 16? Change it into 16i squared. Yes? Because then we can, right over here, square root of 16 is 4, square root of I squared is I all over 2. Then, what do we need to do? Nobody knows. What do you know about the number 2 and the number 4? What I know about them is that the number 2 goes into both of them. So we factorise, and then after we've factorised, not before, we can cancel. Alright, so you must take the common factor out first. Alright, some people like to go, oh, I'm just going to cancel these. It's not a multiplication, so you have to take the common factor out so that you get your multiplication, then you can cancel. Seems obvious, but in the heat of battle in the exam, very easy to overlook that. So the final answer, 1 plus or minus 2 right. All right. Anything in any of that? No. All right. So, mate, we've done very similar stuff to that with real numbers. Now just adding those complex in. All right.